Big news. There's no maybe about it. This planet is definitely the closest planet to the Sun that's not orbiting the Sun. Earth is our paradise in space. Although 7 other planets, a plethora of moons, and countless smaller dwarf planets make up our solar system, the only planet that contains everything needed for life as we know it is Earth. However, we are getting close to when we might have to abandon our beloved planet. This brings us to Proxima b, the Earth-like planet orbiting Proxima Centauri that we might one day call home. But a discovery made by the James Webb Space Telescope has raised suspicions and led researchers to question the purported existence of the planet orbiting Proxima Centauri. It may be damp like Earth, and it feels and looks like Earth. But is this planet our sole hope of avoiding what would otherwise be the certain destruction of everything that mankind has labored to accomplish? Could we actually live there? Join us as we explore the James Webb Telescope's terrifying discovery on Proxima b. After 6 years, nearly every location in our solar system was considered a potential habitat for life. For hundreds of years, the findings from spacecraft missions to other worlds altered that perspective. Only the Moon Mars, and maybe some of the larger moons of the giant planets Jupiter, Saturn, Uranus, and Neptune might support a long-term settlement. The giant planets themselves have no hard surfaces to walk on, and several of their moons are inhospitable to life. While humans have visited Mars and the Moon, NASA research suggests that only Callisto, the larger moon of Jupiter, and Titan, the larger moon of Saturn, could be habitable for an extended period of time. Smaller moons of gas giants, like Jupiter and Saturn, have such light gravity that an explorer's muscles would gradually weaken over time due to the intense radiation fields emanating from the gas giants. That leaves us with Mercury and Venus. Due to its proximity to the Sun, Mercury cannot sustain life as we know it. It is showered in solar radiation and has an average surface temperature of 800 degrees Fahrenheit. Venus is even hotter than Mercury. Lead may be melted at the average surface temperature. The atmosphere is 90 times more pressurized than Earth's atmosphere, which is extremely painful. Can we rule out the possibility of alien life? A significant portion of the motivation for space exploration is to discover the answer. Planets change, that much is certain. Earth today looks nothing like it did over 4 billion years ago when life began. The movement of Earth's surface by plate tectonics has created the continents we see today. A shift from carbon dioxide to nitrogen and oxygen has occurred in the atmosphere. The ocean salinity has also changed throughout history. Due to these changes, all traces of life's origins have been erased. The Earth's magnetic field is created by conductive material located in the center of the globe. Solar wind, which is a powerful wind that could otherwise wipe out Earth's atmosphere, is repelled by the magnetic field. Auroras, such as the famous aurora borealis, often known as the northern lights, are formed when a portion of the solar wind is diverted to the poles in a safe way. Creating life and keeping it alive for an extended period of time until it develops intelligence may depend on these unique Earth qualities or a mix of them. Stromatolites, or fossil mounds, are among the early pieces of evidence of life on Earth. Oxygen was gradually added to Earth's atmosphere over billions of years as a result of these creatures' consumption of carbon dioxide and subsequent release of oxygen as waste. Life that thrived on oxygen evolved. Scientists at our museum, NASA sites, and other labs across the world are still looking for signs of life beyond Earth. Even if we haven't found any yet, there is other life out there, and we have attempted to contact it. A metal record resembling a photograph was among the earliest items launched into space by humans. The records, along with the reading needle, were carried by the Voyager 1 and 2 spacecraft that departed from Earth in 1977. These records featured images and sounds of life on Earth. Who knows if someone will one day hear it? The nearest habitable exoplanet is Proxima Centauri b at a distance of 4.25 light-years. Given its closeness to its host star, the planet is likely tidally locked, facing the star with a permanent day side. How likely is it that Proxima b may support life? That intriguing subject keeps popping up. Harvard University physicist Avi Loeb and astronomer Laura Kerber proposed using the JWST to discover solutions. Scientists can use the JWST to study patterns that suggest the existence of water or an atmosphere on Proxima b because it can capture infrared light reflected off the surface. As astronomer Ed Turner points out, though, just because something has an atmosphere doesn't mean life exists there. Like Venus, Proxima b may have a thick atmosphere and scorching temperatures. Even yet, the method proposed by Loeb and Kerber is still our best bet for getting a look at this. When looking into Proxima b, scientists mostly use infrared image analysis. The finding of extrasolar planets is made possible by the JWST's formidable infrared vision, which captures reflected infrared light. Scientists can determine if Proxima b is encircled by an atmosphere or contains water by analyzing these photographs for patterns. This revolutionary method opens up a world of possibilities and lays the groundwork for future planetary research. Discovering how much water is on Proxima b and whether or not it has an atmosphere are the primary goals of the probe. Potential habitability on Proxima b is boosted by the probability of water on the surface. Furthermore, an atmosphere may disperse heat to the planet's dark side while protecting it from the extremely hot surface. Determining these elements becomes critically dependent on the JWST's infrared image analysis capabilities. However, due to the complexity of planetary atmospheres and the limitations of modern technology, getting definite answers is still tough. According to recent calculations, the deepest exposures of JWST would be able to detect thermonuclear explosions on Proxima b that emit energy equivalent to more than a megaton of TNT. We might direct the telescope to look for strong thermonuclear explosions on the closest inhabited planet, even if these were primarily concerned with finding the earliest stars in the early cosmos. To conduct a thermonuclear search, two obstacles immediately spring to mind. Since thermonuclear battles on Earth are so rare, the first criterion is that the explosion and the observing period must coincide in time after accounting for the time it takes for light to travel. Second, the amount of energy released would be comparable to that of strikes with meteorites larger than 30 meters. Such collisions happen just once every 200 years on Earth. No asteroids larger than 98 feet will be able to impact Proxima b during the JWST's observation run unless the planet is encircled by a dense cloud of them. Rocket launchers are another peculiar light source. The Starship rocket operated by Elon Musk's SpaceX is our most powerful rocket and uses many kilotons of methane fuel each launch. Even at the distance of the nearest star Proxima Centauri, JWST will not be able to detect this, which is the same as a few percent of a megaton of TNT over a long launch period. It is possible that these detecting challenges will resolve Fermi's paradox in a way that is satisfactory. Technological signals that are more easily detectable, such as those imagined for Type 2 and 3 civilizations, which harvest all the energy from their host star or galaxy, should be regarded as wishful thinking, akin to Disney World's Prince Charming or the view through the metaverse goggles where virtual reality meets our desires. Naturally, a technical device's terrestrial visit offers the finest chances of real detection. If the alien spacecraft was decommissioned billions of years ago, it would crash into Earth's atmosphere like a meteor with an unusual composition and look like it came from another planet. Some interstellar objects, with exceptionally great material strength, could be fragments of ancient broken Dyson spheres, assuming the improbable existence of Type 2 civilizations. Atmospheric conditions are a key indicator of a planet's habitability, but they are not an assurance that life exists there, according to astronomer Ed Turner. Life as we know it cannot exist in an atmosphere as dense as Venus. Thus, Proxima b's atmosphere alone does not establish that the planet is habitable. To fully comprehend this extraterrestrial planet, scientists will need to use a wide range of techniques and observations. To grasp the difficulties of investigating exoplanets that might support life, it is necessary to compare Proxima b to Venus. Venus has a far denser atmosphere than Earth, yet the gas giant still gets very hot. Habitability is a result of a wide range of elements interacting in complicated ways, as this example shows. Investigating Proxima b provides a rare chance to learn about the intricacies of planetary atmospheres and the circumstances that are required to support life. Proxima b's discovery is a major step forward in our quest to find extrasolar planets that may be habitable. The JWST's capacity to take pictures of alien worlds opens up innumerable avenues for further investigation. Despite its relative infancy in comparison to Earth, Proxima b demonstrates the immensity of our cosmos and the possibility of life in faraway places in space. Proxima is thought to be 15 to 20 million years old, which is a baby compared to our 4.5 billion-year-old Earth. The genesis and history of the planet are intriguingly cast into doubt by this young age. Sasha Hinckley, an associate professor of physics and astronomy at the University of Exeter, has been able to shed light on the gas giant classification of Proxima b through her observations. The planet probably couldn't sustain life as we know it because it doesn't have a rocky surface. Nevertheless, additional investigation and study can provide a more comprehensive grasp of its distinct features and illuminate its habitability potential. Scientists have a once-in-a-lifetime chance to study Earth through robotic space research missions thanks to Proxima b's close proximity to the planet. Projects like Breakthrough Starshot are working to learn more about Proxima b. To learn more about this fascinating planet, robotic spacecraft might approach it from a closer distance and collect crucial data. A major step forward in our knowledge of exoplanets was the finding of Proxima b by the James Webb Space Telescope. Planets with large oceanic covers, as suggested by simulations, may also have frozen oceans on their dark sides. The presence of water makes Proxima b a potentially livable planet. The model still predicts that the water would be cooler than expected even at that point. This suggests that the planet may still be able to support life despite not being the perfect tropical getaway. Although the planet is quite close to Earth in cosmic terms, it is still a considerable distance for people to travel. Traveling at the speed of light or very close to it would be necessary for human spacecraft to reach the planet at a respectable speed.